And to look at one last example here with a 3-equation, 3-variable system, we want to point out what happens when you've got an equation where you don't have all your variables. Notice we're missing a y term there in what I'd call equation 3. So what this actually ends up meaning is you actually get off with less work if you understand how to utilize it. So recall, in our previous problems, in the steps, we were supposed to take equations 1, 2, and 3, and we were going to eliminate one variable 2 different times, right? Because our goal was to get to equation 4 and equation 5 with the same 2 variables. Well, what this is kind of saying up here is take the equation, or if maybe there's multiple equations, take one of the equations and say that this equation is getting promoted. Immediately think of this equation, the one that's missing a variable, as your first equation in your next system. The reason we do that is we now have an equation in 2 variables. All this does is it forces our hand to use the other 2 equations and to eliminate the missing variable, because we know we want to make an equation 5 in x and z as well. So that's it. We're going to eliminate the y in 1 and 2 to create that equation 5. So let's take a look at 1 and 2 look like here. 2x plus 3y minus 4z equals 4. X minus 6z. All right, so there's our equations, and if we need to eliminate y to end up with an equation to match this guy, looks like all we need to do is multiply that first equation by 2. So we get that. Second equation does not change. And we get 5x, that's gone, minus 7z equals negative 8. And that is going to be, I'll put it up here and I'll bring it down again. Notice that is our equation 5, and that works because it's in x and z. So this is all we have to do. Basically, we're skipping out an entire elimination step by just taking the equation that only had 2 variables and promoting it on. But now we'll look at 4 and 5 like that's our system. So negative x plus 3z equals 8. 5x minus 7z equals negative 8. And I would say simplest here is going to be to eliminate the x by multiplying by 5, because then I'll have negative 5x plus 15 z equals 40, and positive 5x minus 7z equals negative 8. And that will leave us with 8z, because those eliminate, equals 32. Divide by 8, and z equals 4. So there's our first number. Now remember, you go back to an equation with just one extra variable, so back to one of the 4 or 5. I'll go back to 5. So 5x minus 7, but then the z is a 4, equals negative 8. So 5x minus 28 equals negative 8. Add that over, get 5x equals 20, and divide and get x equals 4. And now we got to go back to one of our equations that involved y, so not equation 3 basically. And we'll go with the 2x plus 3y minus 4z equals 4. And plugging these in, I'll see if I can do it right this time, since I messed up on the last video. 8 plus 3y minus 16. That's going to give me 3y minus 8. Add the 8 and divide by the 3. And we get 4. So x, y, z is going to be the coordinate point 4, 4, 4.